Today we are starting new chapter, elasticity. Very often we use the word elastic. Rubber is elastic in nature. That means when you withdraw the force, it returns back. So in terms of physics, we say elasticity is the property of a material to return back to its original shape, after the withdrawal of the deforming force, after the withdrawal of the deforming force. Okay, the reverse of elasticity is called plasticity, in which the body will not return back to its original dimension or original shape after the force is withdrawn. So what are the examples of elastic bodies? The elastic bodies example is a spring, steel spring. You stretch and once you release it, it returns back. Power off. So the reverse of elasticity is plasticity. When a body does not regain or does not return back to its original shape after the withdrawal of the deforming force is called. This property is called plasticity and the body is called plastic. So I was giving the example of plastic body. Normally the spring, once you withdraw, release it, it returns back and tries to regain its original shape and size. So it is elastic. Even the rubber band also has the same tendency. Okay, now in the chapter elasticity we define certain terms. Stress. What is called stress? Stress is the deforming force per unit area. The deforming force per unit area is called stress. Then stress formula we get is stress is equal to force upon area. So SI unit of stress will be Newton per meter square. Okay. Now the second quantity we define out here is strain. What is strain? Strain means with respect to the stress, how much is the change in dimension taking place? That means it is the ratio of change in dimension to the original dimension. It is the ratio of change in dimension. We write here strain is equal to formula. We write strain is equal to change in dimension upon original dimension. That is called strain. So strain has no unit. Because the ratio of similar quantities, dimension, here also dimension. So it has no unit. One example, suppose a wire length was 1 meter original length and we are stretching it or rather elongating it to 1.5 meters. So how much is the elongation? What is the change in the length? 0.5 meter. We write as 0.5 divided by 1 meter. 0.5 meter by 1 meter. Meter cancels. So the strain value is 0.5. The strain has got no unit, but the stress has unit. So there is a law, it is called Hooke's law of elasticity. Hooke's law of elasticity. Hooke's law of elasticity says that stress is proportional to the strength, but within a limit, and that limit is called elastic limit. Hooke's law states that the stress is directly proportional to the strain within elastic limit. Sometimes what happens when you have too much stress, the body does not return back, rather it may break. That time this law will not be applicable. Within a certain limit, stress is directly proportional to the strain. That means when you increase the stress, strain also increases. And when you decrease the stress, strain also will decrease. One simple example, suppose we take a wire, maybe a rubber wire, rubber cord, suspend some weight there. So the weight is the deforming force, the stress is given by that weight. When you increase the weight, the elongation, more elongation will take place, then the strain value will increase. And if you remove the weight, the elongation will decrease. So that means stress and strain are directly proportional. And what can we write ratio like this? Stress by strain is equal to constant, and that constant we denote by E, and this E is called modulus of elasticity. Modulus of elasticity. Modulus of elasticity. Stress by strain ratio is denoted by E, capital E, and we call it modulus of elasticity or coefficient of elasticity. We can say that also, coefficient of elasticity. So, if the value of this ratio is large, we say the body is more elastic. If the value of this quantity is less, we say that the body is less elastic. One question we can think and answer: which one is more elastic, rubber or steel? Rubber or steel? There are two materials. You have to decide which one is more elastic. What is your answer? So then the people will think it is rubber. Rubber, they will think it is more elastic, but the actual answer is steel. Steel is more elastic than rubber. And what is the reason behind? You can say you can give two reasons for it. Which of them will be able to regain its original shape and size more accurately, steel or the rubber? The answer is steel, like a spring. Once you release this spring comes back and it has tendency to acquire its own original position or original shape. Whereas rubber will remain slightly elongated, it will not exactly return back to its own shape. Definitely the steel, because steel is able to regain its original shape and size more accurately than the rubber. So steel is more elastic. But let us give the mathematical answer over here. For that we say, for the same stress in the rubber and in the steel, we find strain is more in case of rubber. Rubber gets more strained, or that the strain value is more in case of rubber. Then the strain, your rubber may get more elongated. When the strain is more, then elasticity will be less. And when the strain is less, then the elasticity is more. One simple example, let us take one rubber string and one steel wire like this. This is rubber and this is steel. Initial length will take same. Initial length is same. Now let us suspend some weight, W. Here also I will suspend same equal weight like this, W. Which will get more elongated? After you suspend hang it, I think this will, rubber will get more down there, more elongated. And steel, with respect to the same weight, it will be getting less elongated. Then your new position of this will come somewhere here, and this will come slightly like this, slightly down like this. This is the new position out here. So what do you see? Strain is more because we are applying same stress, because wire's area of cross section is same kind of wire, and the initial length is same. Then for the same stress in both the rubber and steel, strain value is more in which case? In case of rubber, when the strain is more, then the elasticity is less. That means the rubber is less elastic, or in other words, steel is more elastic. So on this basis, we will be giving the answer. Instead of giving the general answer like that, saying that the steel regains its original shape more accurately than the rubber. Instead of saying that, we will say this answer. We say that for the same stress, strain is more in case of rubber, so it is less elastic, and strain is less in steel, so it is more elastic. Now, there are three types of modulus, types of modulus of elasticity. Modulus of elasticity. There are three types. First one is called Young's modulus. Young's modulus. Second one, I'm leaving. Second one is called Bulk's modulus. Bulk's modulus. And the third one is called modulus of rigidity. Modulus of rigidity. Young modulus is denoted by Y, bulk modulus by K, modulus of rigidity denoted by N, Y, K, N. There are three types of Young's modulus. In Young's modulus, what happens? We will be applying a stress and we will find the elongation in the body, the length of the body is changing. So such a modulus of elasticity is called Young's modulus. The Young modulus formula will get a kind of stress, either side is stress, here also like strain, but such a stress which changes the length, that we call it tensile stress by tensile strain. Tensile stress by tensile strain. Or we can call it longitudinal stress by longitudinal strain. Longitudinal is the word coming from long is lengthwise elongation. So the formula this we can write is Y is equal to F by A out here, and this is elongation. We find that delta L by L, delta L by original length, changing the length for original length. And if you write all together like this, it becomes F by A delta L, and this L will come out. So this is the formula of Y. If we have a heavy string and all, it is quite heavy, then due to its own weight also it gets elongated. When you suspend in the air, due to its own weight also it will get elongated. That time F will be equal to mg. Weight of its own weight is causing elongation. This L is the force that is causing this elongation. That is the value. And what is A? Is the area of cross section of the material. If the material is like wire, the area of cross section will be circular. Their area formula will be like pi r square. So it depends on what kind of material, what is the area of cross section of that. So accordingly we will use this formula. And unit of Y will be same Newton per meter square. Because these two will have, strength doesn't have units, so whatever unit for F by A is left over, that is the unit for Y. Now burst modulus time, what happens? You write K is equal to your force will change the volume of the body. The deforming force will change the volume of the body. That is, this K is written as bulk stress. Bulk is volume wise. Bulk stress by bulk strain. Bulk strain. Instead of saying bulk stress, we can say volume stress by volume strain. Then here the formula I will be writing as F by A. This is for stress divided by bulk strain. Bulk strain I will writing change in the volume per original volume. This will produce change in the volume of the body. That means the value of K I will write like this: F by A and out here V by delta V, like this I write. This is the formula of bulk modulus K. It will produce change in the volume, and this Y Young modulus produces change in the length. There is elongation. It will cause elongation. And K value, K unit is same Newton per meter square, because strain doesn't have unit. Any kind of strain does not have a unit. So the unit of K is Newton per meter square. And volume, we know that solid also has volume, liquid also has volume, gas also has volume. So this bulk modulus is applicable to all three states of matter. All three states. Whereas length, only solid will have length. So this modulus is applicable to only solids. So for gas especially we write this formula. For gas, the value of K is force by area will be called pressure, and here we write V by delta V. And we put a minus sign on it. We put a minus sign, negative sign. That is for gas we write K is equal to minus PV by delta V. Why minus sign? This is the result of Boyle's law. Boyle's law says when we increase pressure and volume are inversely proportional. When you increase the stress, that means you are increasing in a big pressure, then the volume should decrease. That means delta V value will become negative, and K is a positive quantity. To make the entire thing positive, you put a minus one. Here minus sign signifies that the volume decreases with the increase of pressure. This is the result of Boyle's law. So for gas especially K formula we write with the minus sign, minus PV by delta V. What is modulus of rigidity? Sometimes the deforming force will change only the shape of the body without changing its dimension. Then such a modulus is called modulus of rigidity. And this modulus of rigidity will come into play when the force is acting on a body tangentially, like just surface wise. Suppose we have a body and we are giving a force like this way. So its volume remains the same, even the length also does not change, or there is a very minor change in the length, but its shape gets distorted and its shape changes. Shape gets deformed. So such a modulus is called modulus of rigidity. So for this we write the formula like this: N is equal to, here we say shearing stress by shearing strain. We say that this is the ratio of shearing stress to the shearing strain. Shearing stress time we write like F by A, and the change in the shape is measured in terms of the angle. By what angle it is, the shape has changed. So F by A by theta we write here. And this SI unit is also Newton per meter square. And but this force and the previous is the force here and force here, these two forces were acting normally to the surface, normal to this area, normal to the area of cross section, and normal to the cross section of the body. But this force is a tangential force. It is acting in a tangential way like this. Okay. Rigidity, modulus of rigidity is also applicable for solids only, because liquid and gases, they do not have shapes, they do not have fixed shapes, so there is no question of changing the shape. So only bulk modulus is valid or applicable for all the three states of matter, whereas Young's modulus and modulus of rigidity is only applicable for solids. So our today's lesson is this much. Thank you.